morning, ladies and gentlemen. Today I will present you results of my PhD work, some part of it, connected with opportunities and challenges of automatic landslide detection, and here I will focus on object-oriented approach using digital elevation model. I will present briefly a motivation and innovation of this approach, methodology, and conclusions. As we know, landslides are very dangerous nature hazards and occurring worldwide. And in the world here we can find the fatalities which were caused by landslide activity. So we see that problem is very important. In Poland we have also a lot of landslides, however we have them mostly in Carpathian mountains. And here is the density of landslide in Carpathians. This is the issue, the reason for landslide in our in this study area is geology, and triggering factors mostly connected with precipitation, and we are facing mostly with damages of the buildings and infrastructure, and fortunately we didn't have any fatalities caused by landslide. The topic is important, and we have the landslide inventory map. However, this map is produced by conventional field investigations, connected or supported with the visual interpretation of the topographic map, of the geological map, of the LiDAR right now. But this is only visual interpretation. And having in mind the availability of the data, Earth observation data from LiDAR, remote sensing, and from another side, the IT support of machine learning, deep learning, and so on, the question arises if we can detect landslide and produce such maps using automatic approaches. So topic is innovative, not easy, challenging, however, worth to investigate. In overall, the methodology of workflow is presented on this flow chart. From LiDAR point cloud, we are generating digital elevation model, then we generate another derivative, slope, aspect, etc. And then we can perform classification either pixel-based or object-based. But then we are using supervised approach for classification, and we need for that ground truth data, which are used for training and also for validation purposes. But when looking at that workflow, we have many questions. Firstly, which DEM, what DEM resolution we should utilize, what DEM derivatives we should use, because there can be many of them. We should follow the pixel or object-based approach. We should, if object, what segmentation scale you should utilize, because it's the most crucial thing. And then we have so many deep learning, machine learning approaches. So which classifier we should use for supervised classification? And for supervised classification, we need training samples. So how many of them we should use? 10, 5, 15%. So there's many questions which I tried to answer during my PhD road, and I will present here only a few due to the time limitations, and which are presented here in the right corner. So firstly, optical pixel. So in one study, I perform object-based classification with overall accuracy of 85% and kappa 0.6, and in another I perform pixel-based with this accuracy measures, and we can observe that object-based is better. So when it comes to object-based, then what resolution, and here for different DM resolution we check the accuracy, and we see that the highest kappa and accuracy is observed between 2 and 5 meters, and then the accuracy and kappa is falling down. So we should select this various DM resolutions for effective landslide detection. When it comes to scale, we can also see that somewhere here is this range of the optimal segmentation scale between 20 and 40. So we should utilize this resolution and this segmentation scale for the landslide detection. Then when it comes to training samples, how many of them we should utilize? And here I perform a so-called region growing landslide detection, where in my study area I split it in some many subsites, let's say, and here in the center I locate my training samples, and I evaluate like region growing study area, because the contribution of my training sample in each of this growing study area is different. And also I didn't want it to use training samples located randomly, because I don't want to introduce autocorrelation. So this approach gives me the feeling and the results that when we want to achieve the F1 score, this is another parameter of accuracy measures which is useful for unbalanced data, we should have around 50, not less than 30% of the training samples to achieve this accuracy, this index of 0.5. So we can see that the accuracy is falling down in reference to decreasing amount of the training samples. So the conclusion is that the training and testing sites should be similarly large. Following this conclusion, we do another training with more reasonable solution, that we have the inventory for the one side of the river, and then we want to check on another side or run the algorithm on another side, and we have the results here. So this is the result of this automatic detection, and true positive are green and false positive as this rose or violet color. So you can see that we have still many false positives in this approach, and this approach is based on object and refinement of this results. Also, it integrates pixel based approaches, so it's like integration of many steps. However, when it compares to this achieved in literature, we can see that this is the level of the where we are right now. So we on the level of 80% in overall accuracy, but we should consider another indexes for unbalanced data like kappa F1 score to see the performance of this accuracy. You can see that we have here 0.5, 0.6 sometimes, not more. So still there's room for improvement. Nevertheless, we have many. These methods can bring us many opportunities. For instance, in highly vegetated areas, in dense forest, where experts identify 2 different landslides in our landslide inventory map. However, observing LiDAR or DM, you can see that this one object, one complex landslide. So it is possible due to the remote sensing data. However, when we have very changing or heavily changing area like agricultural areas where many agricultural treatments are taking place, so we see that these automatic approaches fail down here, and mostly because this characteristic landslide features are not observed here. So mostly due to the changing terrain or denudation or another phenomena. And also going to the field to see this area, we can see the agricultural fields. So and characteristic landslide features signs are not visible, so it's very challenging to see and to say that this is landslide, and we should investigate historical data to check that if this is really a landslide. So it's also very challenging sometimes, not only for automatic approaches but in general. We should also focus on another aspect, that we treat landslide inventory like ground truth, but we should think also that is it really a ground truth, or like here we have some training samples which were used to build a model. So we see that observing this LiDAR results, we see that there's no characteristic landslide features. So is it really a landslide? Maybe in history there were some landslides, but right now it's a long time ago, and we cannot see this characteristic topography and changes like here, this roughness, etc. So maybe we shouldn't run this algorithm for all inventory, for the total amount of landslide in the inventory. We should maybe limit ourselves to the recent landslide to better train the model. So such a multi-temporal approaches are more preferable than having all inventory, all database as ground truth. So conclusion of this is that from another side we have this conventional methods. Here we have this automatic approaches. So we should integrate both to provide precise and accurate landslide inventory map at the moment, and of course focus and try to achieve better results in the future for automatic approaches. And based on my investigation, we can say that the finest DM resolution is not always the best choice, and object-based image analysis provide better accuracy than pixel-based. Training samples should be similarly large as testing areas, and both methods, OB and pixel-based, have limitations of landslide detection in highly agricultural areas. And here are another references when I investigate deeply another aspects. If you are interested, and here are the conference paper published in this book of Landslide Forum, where I discuss these different topics. And here another references. And thank you very much for your attention.